Hello Calculus. You'll be watching this video Wednesday. It's the 5th. It's after sometime after our class on Wednesday. I will play a game with you today and see if I can straighten it up a little bit more. Sorry. I'm not very good at doing this and the camera work. I'm going to give you the graph of a function, and you are going to give me the graph of its derivative. Then we're going to switch places. Let's see how this works. Suppose I give you a function, and it goes straight like this. So here's the function. It's a straight line like that. So how would its the graph of the derivative of this function look like? We know from our discussions that the derivative of a function is another function. So let's see what it looks like. It turns out that if we think in terms of slope, we'll be able to do these well. So this one is a straight line. So what do we know about the slope of a straight line? It's everywhere the same. So can we kind of guesstimate what the number is? Is this slope negative or positive? You'll recall that when it leans in that direction, we do have a negative slope. So this negative slope, we're expecting, I don't know, like if it was -1, it would cut the quadrant 2 right in half. So it's higher than -1. Let's say it's -2. So we would come down here and we would graph a straight line at -2. Do you see how the slope of this line is captured in this function? This function is everywhere equal to -2. And the graph, the function's slope, is everywhere equal to -2. So this is a picture of the function. This is a picture of its derivative. All right? So let's get that down and we'll erase that and do a second one. All right, this time we're going to look at a function that, say the function, that's a little too big. I like to put the function above the derivative graph so we can compare different spots right at the same x values. All right, so let's look at this function. We'll say the function is the smiler. All right, so the smiler is smiling at us with a slight tease in his grin because he wants to know what is the picture of the derivative of this smiler. Again, we got to think in terms of slope. So let's go up here and talk about slope, and then we'll draw the graph down here for f prime. So the slope here looks like this. And as I get closer to this value, the slopes are changing. Then the slope looks like this, and like this, then like this, and then like that. So I'm just going to make up some numbers so I can convince you of what the slopes are doing. So here it looks like it's a very high negative number, less of a negative number, less, and then finally the slope is 0. Then I have a small positive number, steeper and steeper. So putting those actual made-up numbers kind of helps me visualize the change in slope across this graph. So I've got to come up with a picture here of that. So again, the value of the slope, say, is -3 at this value for x. So down here, I'm going to have a -3, say. And then when I come in closer, the slope becomes a -2. And then when I came in closer to the origin, the slope is a -1. At the origin, the slope is 0. So if I'm picturing the slope, you see what is happening here. And on the other side, at this value for x, the slope is a positive number, not so large, then a larger positive number and a larger positive number. So connecting those should be a straight line. So this is a picture of what the slope is doing on this picture. And again, this is supposed to be straight. So make yours nice and straight. Notice when this was a quadratic, this was linear. How about that? All right, let's try another one. Hopefully you'll get the gist of it. It's one of those things you probably don't do very well until you practice on your own. But I'll give you the tools. All right, this time the function is going to look like this. And I am wondering what the derivative looks like. Pause and see if you can at least map out what's happening to the slope. Do a couple points along this graph and map out what you think the slopes are looking like. And then give it a try to change that from the function to a picture of its slope. All right, if you're back with me, way over here at this x value, I'm finding that the slope is a positive, high positive number, less of a positive number, 0, a slight negative number, slight negative, more of a negative number. Do you think it's steeper there? I do. And then here, less steep again in the negative direction, and 0 again. Positive, not so steep, and then very steep. So I put in some numbers, and hopefully yours were mapping that. Positive slopes to 0, then negative slopes to 0, and then positive slopes to 0. Try to graph numbers such as these below. Right, when you do that, notice on this side we had a positive 3, and then a positive 2, and then a 0. So the values of this graph are the slopes. So I'm at 3, 1, 2, 3. I'm at 2. And then at this point, I have to be all the way down at 0. So when I'm doing that, it's going to look like this. And then I'm going to start back up in the negative direction. And when I get here, it's more negative. And this one was -1, -2, maybe this was -3. So the slope is a negative value. So that's not right. Sorry. So let's do this again. Over here, the value for the slope was 3. So I'm up here at 3. Then it was at 2. Then it was at 0. Then what happened? It went negative. So I've got to come down here. Then it was -2. So I've got to come down further. Then it was -3. So I've got to come down further. And then I messed up on this. So this is yeah, that's right. So this is a negative, oh, this is less slope, that's what's the product cut. So here, I had a mistake on my slope map. Here, the slope was negative, not too much, more negative, but then less negative. So it became a -1 here. So let's see what happens on our graph. If I'm at 0 here, -1 here, -2 here, and then back to -1. See how it had to curve back up? Then the slope was 0, and then the slope was 1, and then the slope was 3. So here's the shape of the derivative curve. So we went from a cubic function to the derivative being quadratic. How about that? All right. We have to go the other way as well. So let me show you how that works. This time, I give you the derivative and you give me the function. We'll just do one and say that the derivative is a picture of the derivative looks like this. All right, that is a picture of the slopes. So let's go down the stairs here and go backwards. We're going to say, what graph has the slopes that are pictured here? So let's put in some numbers just for fun. 1, 2, 3, 4, 5. So here, right here, the value on this graph is for where x equals 2 is a very high number, close to 5. So I've got to draw a shape with a slope that's very high. When I got to here, the slope is less. It's down to 3. So I'm going to curve less, so my slope is less. And, going the wrong way. The slope here is 3, so I've got to curve this way. Because I need slopes that are very, very steep, like 3. Then, or 5 actually, that was. Then 3. So I'm going to be less steep. Then 2. Then 1. And finally 0. So I'll try to make it a little steeper. And it's going to reach a 0 slope way over there. So by the time I get here, the slope has to be 0. Now, can you tell me which way the slope is going to go after this? Is it going to bend and go back up? Is it going to keep going down? Well, according to our graph here, the slopes were -1, then -2, and then -3. So the slopes are going down, so I have to draw a figure with a slope that is going down. All right. So notice the function, when the derivative is a straight line, the function is quadratic. All right, we'll put this together with some practice soon, so bring this with you in your minds and in your hearts. All right, till then, bye.